Hello students, today's agenda is to check homework. You will be working or actually continue to work on systems of linear equations in word problems, and you will be able to do 5.14. So today students will be able to set up a system of linear equations from word problems and find the solution. Okay. So the first one says, I am 3 years older than my friend. I can immediately see that this is a comparison. Yes, okay, and so it's going to be a variable equals something else. Together means addition, so plus our age is 31. Okay, so we can see that the keywords is I am 3 years older than friend. Okay, together we're 31. So for the first comparison, remember that when you see the word is, which is similar to it comes from the same family of words to describe to be. That means equal. Okay, so oops, I am. Remember also that the word than, we switched the order, and if you don't remember, you can just look at previous lessons so that you can look at this vocabulary, but we switch the order. Okay, 3 years older than, so 3 years older than my friend. So I'm just going to represent my friend as F. So I am 3 years older than my friend. Okay, and just because of that word, it switches the order. Friend first, 3 years older second. Okay, and I am, remember that the word am or is or will be means equal. For the second equation, it says together, meaning my age and my friend's age, together it is 31. So I plus friend equals 31. So those are my two equations. Now I have to decide which method of the methods that we learned is better: graphing, elimination, or substitution. And basically graphing can be a little bit complex because it's not as accurate unless you're really good or you have a graphing calculator that you can do this work for you, and only if your teacher allows you to use it. Elimination, that's when your I and your F would be on the same side of the equal sign, but for the first equation we don't have that set up, and we can easily set it up that way. If you prefer that, you can subtract F from both sides and have minus F, and the answer will be I minus F, so that way it can help you eliminate the F. However, if you prefer to use it the way it is, whenever you have one of the variables isolated, that means that the value of that is all of this. And on the other equation, you can just take out your I, take it out, and in its place replace the value of that variable. Why? Because it's just like saying $20 is equals to 10 plus 10. So I can take away the $20 and replace the 10 plus 10 in its place. Okay? So let's do that. It's gonna be, instead of I, I'm gonna put F plus 3 plus F equals 31. I combine like terms, and so F plus F is 2F plus the 3 in here is equals to 31. Then I subtract 3 from both sides, and so 2f is equals to 28. I divide both sides by 2, and f is equals to 14. So that means that my friend is 14 years old. How old am I? Well, it says I am 3 years older than my friend. So I'm going to use the first equation. I am the age of my friend, which is 14, plus 3. And so I am 17 years old. Okay? So now let's check. If I am 17 and my friend is 14, am I 3 years older than him or her? Yes. Are our ages together 31? Well, if I add 7 plus 4, that's 11. I put the 1 and carry 1. 1 plus 1, 2, and 1 that I'm carrying is 3, so yes. So it checks for both of these sentences, okay? Okay, for the next one, it says, the sum of two numbers is 20. Sum of two numbers is 20. So that's easy, right? I add two numbers, and it doesn't matter the variables. I can use n plus n equals 20 or x plus y equals 20. That's fine. Then in here it says one number is, oh, it's a comparison because this means equals. A number equals 5 more than, oh, that word, double the other. Not only more than the other, but more than double the other number. Okay, so for the first one, it's very simple. It says that the sum of the two numbers, so I just put the two numbers together in an addition, is 20. For the second one, for the second sentence, it says one number is 5 more than. Remember that when it says 5 more than, it's like we start from the end. 5 more than double the other. So if I already used x, now I have to use y. So double the other. Remember that double or twice is the same thing as multiplying times 2. Okay? Now, once again, we can see that one of our variables in one of the equations is isolated, so we can just replace in the other equation, substitute by removing that x, and in its place, we put the value of x. It's like taking out the $20 bill and putting the 2 tens, okay? So, instead of x, it's going to be 2y plus 5 plus y equals 20. We combine like terms. 2y plus y is 3y. And then plus 5 is equals to 20. Some people sometimes have questions of how come this is 3y? Remember that if there is no coefficient, it means that there is one y. The coefficient is 1 for y. Okay? We subtract 5 from both sides, and so 3y is equals to 15. If we're multiplying, we're now going to divide, and so y is equals to 5. So we already know that y is 5. Now we can figure out the value of the other one. Now somebody asked me, can I choose any of the two? And the answer is yes. And you know what? I think I'm going to do it for both of them so that you can see that it doesn't matter which of the two equations you choose, you should get the same value for x. Okay? So let me use the first one. X plus y, but instead of y, I'm going to use the value. 5 is equals to 20. I subtract 5 from both sides, and so x is equals to 15. So that means that one of the numbers is 5, the other number is 15. Okay, that should be enough. But I'm just gonna show you that it doesn't matter for the second step, it doesn't matter which of the two equations you choose, you will get the same answer. So in here it says x is equals to 2 multiplied by y. We already know that the y is 5 plus 5. So x is equals to 2 times 5 is 10 plus 5. So x is equals to 10 plus 5 is 15. If you notice, it doesn't matter. I used the first equation and I got 15 for x. I used the second equation and I got 15 for x. Okay, so my two numbers are y is 5, x is 15. Now let's see if it checks with what it says in here. The sum of two numbers is 20. If I add them, is that equals to 20? Yes, because 15 plus 5 is 20. Then it says one number is 5 more than double the other. So one number is 5 more than double the other. So I have to double the other one. Double 5 is 10, and it's 5 more than that. So 10 plus 5, 15. So yes, it makes sense for both of them. Okay. Okay, it says this guy buys watermelons and cantaloupes. He buys 5 times as many watermelons than cantaloupes. He buys a total of 12. Okay, so what are the keywords in here? He buys watermelons and cantaloupes. He buys 5 times as many watermelons as cantaloupes. Okay, so which one does he buys more of? And this is the way it's worded. That's when it gets really tricky. Okay, but those are the keywords. He buys a total of 12. That means if we buy a total, that means that we're adding them together, right? So total of 12. So let's start with the last sentence to make our first equations, and since that's easier, we know that our watermelons plus our cantaloupes is equals to a total of 12. Now the next one is a comparison, and we just need to check which one has more, okay, or which one we're comparing with. He buys 5 times as many watermelons than cantaloupes. That means that he has to multiply the number of cantaloupes times 5 to know how many watermelons he buys. So the number of watermelons that he buys is the same as whatever he buys of cantaloupes multiplied by 5. Okay, he buys 5 times as many watermelons as cantaloupes. Okay, again, we need to know how many cantaloupes he buys. He multiplies that by 5, and that's how many watermelons he gets. Okay, which method would you use? Again, we see that the W is isolated, and so we can just, in the other equation, replace that W with the 5C. So instead of W, 5C plus C is equals to 12. We combine like terms, and so we get 6C is equals to 12. We divide both sides by 6, and so C is equals to 2. Okay, so how many cantaloupes does the guy get? 2 cantaloupes. How many watermelons does he get? 5 times the number of cantaloupes. So the watermelons that he gets is equals to 10. Now, let's see if this makes sense. He buys 5 times as many watermelons than cantaloupes. So if you notice, yeah, he has 5 times as many watermelons as cantaloupes, because we multiply 5 times 2, that's the number of watermelons. He buys a total of 12. Together, they make 12. Okay? And there is a joke that we found with Mr. Cantera. Actually, he found this. It's a joke. This is the person your algebra problems warn you about. You know, this is a lot of watermelons right there. So, who buys 10 watermelons? Well, you'd never know. Okay, let's go to another exercise. And so it says, you buy a watermelon at $6. Look, you buy watermelons at $6 each and cantaloupes at $2 each. I think it's missing an S in there. You buy 3 times as many watermelons as cantaloupes. If you spend $540, how many of each did you buy? Okay, so what are the keywords in here? There you go. So you buy watermelons at $6. We don't know how many watermelons. We buy cantaloupes at $2. You buy, you know what? I want you to notice that in here, since we already read it once and now we're just identifying the keywords, I want you to notice that this is talking about the price, and you might as well just connect it to the price in here. You spend $540. So that's one of the equations right there. And this in the middle is the other equation, but it's a comparison and we'll come back to that one. So my watermelons, and I don't know how many I bought, multiplied by its price, plus my cantaloupes multiplied by the price is equals to the total price. Remember that when we're talking about the price, then we connect it to the price for all of them. The other one is a comparison, and it says you buy 3 times as many watermelons as cantaloupes. Again, you're comparing and you're saying that you're buying more watermelons, so you need to multiply your cantaloupes by 3 to know how many watermelons you're buying. Okay, 3 times as many watermelons as cantaloupes. So you're comparing with the cantaloupes, that's what you're multiplying by the 3. Okay, 3 times as many watermelons as cantaloupes. Remember, wherever you're comparing with, that's what you're doing to those cantaloupes. Okay, now that I have my equations, I notice that the W is isolated, so I can use substitution method again. So I'm going to replace this W, that W, with its value, which is 3C. And so I start writing 6 multiplied by 3C plus 2C equals 540. And so 6 times 3C is 18C plus 2C is equals to 540. I combine like terms, so 20C is equals to 540. We divide both sides by 20, and so my C is equals to, let's see, the 2 goes into the 5 2 times. 2 times 2 is 4, 2 5 is 1. The 2 into 14 goes 7 times, and there is no leftovers, and so that's basically just canceled. So that was a fast way of dividing, but you can always do the long division if you want. Okay, so now I have that I bought 27 cantaloupes. Now how many watermelons did I buy? My watermelons are 3 times as many as the cantaloupes that I have. So 3 times 7 is 21, carry 2. 3 times 2 is 6, and 2 is 8. So 81 watermelons. Wow. 27 cantaloupes and 81 watermelons. So I need probably something bigger than this to be able to carry them. Okay. So that's what you will need to be able to do 5.14, and I hope you have fun. And I hope you don't buy as many cantaloupes and watermelons as this guy. Okay.